Uh, Welcome everybody. Today we're going to be talking about how to make your everyday home into a makerspace, and we're going to be doing a few projects. So to introduce myself, my name is Naved. I'm an instructor with MakerState. We're a STEM education program located in New York City, and we've been doing the STEM programs for a while now, and this is our first time going virtual. So it's an exciting time and as well as a trying time for everyone. And with me today, I have Hanna. Hanna is also an instructor with us, and as well as Stephen Gilman. Stephen Gilman is our executive director. Stephen, do you have a few words for us?
Oh, no, you're doing great, Naved. Carry on.
All right, awesome. So what we're going to be doing today is just a few projects that you can do from home that teach scientific concepts. And some of these projects, the projects that we're going to be doing today are the materials are very easily found. If you don't already have it at home, you can grab some from your local grocery store, anywhere nearby. And of course, we want to make sure that you do all of this safely. So we're trying to minimize the amount of materials you need for the projects. So we're going to go through two projects, and if we have enough time, we will try to get to a third. And yeah, so I think the first project we're going to start with is a fun experiment that shows us the power of soap. So I'm going to hand it back to Hanna, and she's going to walk us through that.
Awesome. All right, everyone. So nowadays, especially with all that's going on, we want to make sure we wash our hands. It's really important that we get everything off our hands, especially germs and anything else we touch. So for this experiment, we're going to need just a few simple items. You can just grab this in your kitchen. You're going to need a plate. You could use a bowl, but a plate would work better for this experiment. You can use any type of water. It doesn't have to be like distilled. I'm just using Aquafina. Black pepper, and you also need some dish soap. So I'm gonna wait for everyone just to get some of those materials. But in the meantime, let's just ask a few questions. So who knows, and you guys can just answer in the chat, who knows why we wash our hands? I'll give you guys just a second, what that does, and how that's gonna help. We're gonna have a visual for that. Getting rid of germs. Awesome. Let's see if I can just get a few more responses while everyone gets their supplies. So you COVID-19, that is true. That's really important. We wash our hands to help not spread germs, stay safe from bacteria and virus. Exactly. Those are all really good responses. So we're now going to jump right into the experiment. I'm going to push this back for you guys to see. So with this plate, you're going to take some water, and you don't want to spill the water out from the plate. You want to have just enough to where it creates a meniscus. So I'll pour just a little bit in. Let me see. Make sure you wash your hands enough. Oh. That's great. That's a great answer, Cynthia. Awesome. All right. So now we're going to grab some pepper, and we're going to try this both ways. We're going to try without the dish soap and with the dish soap. So you're going to sprinkle some pepper over your plate. And it doesn't really matter how much you use. That all depends on just how much you want of a visual. So for this experiment, there aren't exact measurements because it all depends on what you're using. So I'm using a small plate, and I'm using just a little bit of pepper because I don't have that large of a plate. But if you do have a larger plate, you could use more pepper.
Hey, Hanna, what does the pepper represent in this experiment?
So in this experiment, the pepper represents the germs, or just the virus. It can represent dirt. It represents everything you're trying to wash off your hands when you do wash your hands with soap.
Awesome. Thanks for that.
Great question. Alrighty. So now I want everyone to write in the chat what you think is going to happen when I just dip my finger without the soap. I want to hear some of your ideas. The pepper will stick to your hand. Pepper will stick to your hands. Let me stick to your finger. Is there anyone who thinks it isn't possible to stick to my finger without the stick? Maybe it'll explode. Maybe we haven't tried it yet. Just kidding. Any other ideas? The pepper will move away. Okay, that's a good prediction.
Oh, somebody's already done this experiment.
Awesome. Let's see if I can get at least 3 to 5 more predictions. It will move around. Pepper will stick together. That's interesting. Okay, so the question was, what do you think would happen if I stuck my finger in the pepper with the water with no dish soap on my finger? Nothing. It will not move. Awesome. Okay, so I'm going to now show you what happens without dish soap. Nothing happens. So you guys are right. Nothing's going to happen. It's just going to stick to my finger, which basically means I did not wash off the germs. All the germs are still on my hands. The water didn't clean it off as well as it should have. So we need to try something else. So now I'm going to ask everyone, and I want as many answers as I can get. I know there's a lot of you on here, so I want everyone, or at least most everyone, to participate and tell me what you guys think. I want you guys at home to dip your finger in some dish soap, and don't stick it in the water just yet. I want everyone to predict what's going to happen now when I stick my finger in the pepper and water. It will disperse. Any? It might stick to my hand. It might. We don't know. We'll see. Bubbles.
Mm-hmm. That would be fun.
That would be fun. The pepper will move away from your finger. The soap will act like a shield. Awesome. And for those of you doing this at home right now, I want you guys to try, without doing the experiment, I want you guys to try to think about, with your prediction, why you think your prediction is going to occur. So if you think that the bubble, or if you think that by sticking your finger in the mixture, that there's going to be bubbles, I want you to think about why there might be bubbles, or why the water might disperse, or the pepper, why it might disappear. Just keep those in mind, and then we'll talk about it at the end. Let's see if I can get a few more predictions. Is there anyone who thinks nothing will happen again? anyone think that when I stick my finger back in the water, it's just going to be the same as last time? The pepper is just going to stick to my finger and nothing's going to happen.
It might be a possibility.
It might be a possibility. It'll be a slight improvement, but maybe we might need something else. That's a great prediction. No? No? All right. It seems like most of you think that the water and the pepper is going to disperse. Okay. It seems as if some of you might not know where the chat is. So if you go to the right and you click on chat, go over to session, and then you can just type your response. So I'll type something in the chat for you guys to see. Because I spelled everyone wrong. Wait, no, I can't see from back here. My computer is pushed back. Oh no, that's right. All right, so we're now going to stick our finger into the water with the pepper, and we're gonna see what happens. So let's see if you guys can see this really well. All right. Ooh. Awesome. All right, so as you see, the pepper all ran to the sides. It almost made like a perfect circle. There's some pepper that still stayed, and that's normal. And we're going to talk about why some of it stayed. I'm going to give you guys a chance to try yours out at home. Here, I'll just keep mine so you guys keep looking at it.
Hey, Hanna, do you think you could do that experiment again?
I can, actually. I just have to dump out some of this water. I have
No problem.
A bowl right here.
And put some more pepper in there. We want to see all the dirt.
I'll do all of it. Okay.
And remember, everybody, pepper is the dirt, right? Germs, dirt.
Dirt, germs, coronavirus. Okay, so I'm going to demonstrate this again. For those
you can try it. Aubrey, I see that you're asking if you don't have pepper, can use another spice. Try, definitely try. This is all about experimentation.
Yeah, go ahead and try. I'm going to put a lot of pepper this time. We're going to really get a good visual. We're going to try to. All right, I think that's enough. Okay, all right. I think I have enough soap. Any other? Okay, yeah, so like Naved said, you could try it with something other than pepper. That's all about science, a bunch of trials, and seeing what works and what doesn't work. So I'm going to do this again for those who didn't see it the first time. So I just have a plate of water, and I have some pepper sprinkled on top.
Wow, very cool. What will happen if you color the water? Well, I think the fact that the plate is white, the black pepper is darker, and we get a really good contrast between it. But if you color the water, that pepper might start, kind of blending in with the water if it's not a light enough color.
Right.
So you have to just work with a little bit of contrast.
Right, and this experiment can be done with milk and food coloring as well to get a more colorful visual. What you could do is with another plate, same exact amount of liquid, you would just pour milk and put some food coloring all around, use some dish soap, and same thing, the dish soap will have the colors dispersed to the sides, and it'll be more of a colorful experiment without the pepper. Latanya, so it's just more of the visual, it's the contrast, so you could see what it looks like, as opposed to if you were to use like a gray plate, you wouldn't really see the pepper as much. Awesome. So I want everyone in the chat to let me know if this happened with your experiment at home or if something different happened. And then we are going to talk about why this happened.
So Hanna, what do you think might happen if I used a soap that just wasn't as effective?
So if you use a soap that wasn't as effective, the pepper would just kind of stay. It wouldn't move as much. So you could use, you could do the same experiment with, say, something like hand soap or like a bar soap. And although it would disperse, it wouldn't move too much. It wouldn't try to push out to the edges. And the reason that the pepper does disperse is because the water, it has surface tension, and the surface tension gets broken with dish soap. So you want to try, and if this is, you can compare this to washing your hands. If you wash your hands with just, let's say you wash your hands with milk, you know, you're not going to get too much of, you're not going to clean your hands too much. It might, even though realistically milk wouldn't clean your hands at all, it's not going to do as much as something as dish soap or antibacterial hand soap would. So you could try this.
Oh, basil leaves, awesome.
Basil leaves to know. Oh, basil leaves work? Oh, that's awesome. And Timothy, you did try it with the milk. Awesome.
Dried, definitely. So back to what Hanna was saying about that surface tension, and it's kind of like when we have dirt stuck onto us, dirt stuck onto our plates. What that soap does is it gets underneath that dirt, so that way it can kind of push it off, right? You want to break, it wants to break that connection that dirt has with the whatever, your hands or the plates or whatever you're washing.
Right. And so when you do this experiment, the pepper tries to run away to the sides. Because of the surface tension being broken, the water molecules, they're so strongly attracted. You could try the same experiment with a different liquid. The reason we use water is because those molecules are much more attracted than say like melted ice cream. You know, you want to try to use something with a much more strongly attracted molecule. So once the molecules try to run away, they take the pepper with them. And as stated before, this is a much stronger reaction with this type of soap as opposed to bar soap going through. Awesome, Timothy, it ran away. Cool. All right. Basil leaves work. Did anyone else at home try it with something other than pepper? Or did everyone try pepper? Let me know in the chat what you guys tried it with. Timothy tried it with pepper. Awesome. Right, and if you want, you could totally try this again. You could try it with as many things as you want. Would dirt be too heavy? You could try to see if it's too heavy. I think there has to be something that floats on top. I think dirt would sink underneath the water. So something light, and because you don't want to break that surface tension. The surface tension is, the soap is what's going to break the surface tension and make it spread out. So you could use something, maybe even like a powder, like a grounded type of spice. You could try that because I don't think that will go through the surface tension as much. But definitely something like pepper is super light. It won't go underneath. It kind of floats on top. You could try dust, Amy. You could. I don't know if dust sinks, but it's worth a shot. Dust might dissolve. It could, but that's all. That's the whole point of science. You just want to keep trying, see what works and what doesn't work. What about onion bits? I believe so. Are you, Latonia, do you mean maybe like onion powder, like something, or onion garlic powder? You could try like onion and garlic powder. I don't know if that sinks or if that floats. I believe it floats. I know when I'm spicing some stuff and I have liquid on top, it does tend to stay without sinking. Alrighty, awesome. So Very cool. So basically this experiment just shows that you want to wash your hands to get everything off your hands. If you were to just wash your hands with just water and not wash your hands at all, you have the potential of keeping all these germs, keeping all this dirt, keeping this virus still on your hands. And then you go and touch everything else and it spreads. And we want to make sure we use something that is really good, something with antibacterial properties in it. So not just some normal shampoo or water. So you want to use something like soap or drink. Timothy, you asked what's the other one? Were you referring to the onion and garlic powder? I'll type it. We could try that. No? Go ahead and type your question in the chat. And then you guys can go ahead and ask any final questions. Go ahead and let me know if you like this experiment. And after, what is the other experiment? The other experiment you could try with milk. So you could just take the same plate, use some milk instead. And instead of pepper, you could just sprinkle food coloring all around, use this soap, and it'll disperse to the sides, and it'll just be a colorful experiment. So I'll type that in the chat for you. Awesome. Very cool. All right. Thank you guys so much. I'm going to hand it over to Naved now. And
all right.
He is going to create something really cool with you guys. So thank you guys so much.
All right. So for our next lesson, we're going to explore the science behind flying, right? So right here in my hand, what does this look like I have in my hand?
Could be a cone.
Cone. Okay. Any other guesses? An airplane. Okay, Shantea. A jet. All right. Yeah, we're getting very creative with it. But yeah, an airplane, right? And what does an so an airplane is really heavy, right? It's super heavy, but somehow it still gets off the ground, right? We're much lighter than airplanes, but we cannot fly like airplanes. So yeah, so this is a paper airplane, and this isn't what we're going to be building today, but I just want to use this as an example to show you a few ways how the different forces work together to keep an airplane in motion in air. All right. So what I want to show everybody is this quick little whiteboard right here. So what you see here, right here in the middle, is you have my my little airplane, and I have some different arrows pointing towards it, right? And what you want to think about is kind of like where the arrows connect to the plane at the dot. That's kind of like me holding a string there and pulling it. That's me holding a string here and pulling it. Same thing up here, pulling it, right? And these are the different forces that are in play when you're flying an airplane, right? And you might not have even thought about, is that better for everybody to see?
Maybe you can move it just a little bit, tilt it forward a little bit. Yeah, that's good.
All right. Okay, awesome. So I want you to imagine having a string here, right? So if this airplane is flying and this string here, this imaginary string is being pulled down, what force do you think that is that's causing this airplane to be pulled down? Gravity. Good job, Violet. Yes, exactly. So let's write that in here. Let's write in gravity. All right. Did it come out backwards for everyone? I think it might be backwards.
Move it a little bit closer.
Yeah, it comes. Okay, so the camera flips the screen. Yeah, the camera flips the screen on my end. So it's going to come out like I'm writing backwards letter or even a different language. All right. So yeah, so gravity is pulling it down. All right, now the other three forces you might not be super familiar with, but let's say you want to pick something off the ground. What would you do to take it off the ground? This word, it starts with the letter L. What's another word for picking something up that starts with the letter L? Lift, exactly. So if I'm imaginarily pulling on the string upwards, this force that's pulling it upwards is called lift. So we're going to call that lift. Now, remember that lift is actually fighting gravity. So if I'm pulling this down, lift has to pull me up. And these forces have to equal each other for it to be at a specific altitude. Now, if, for example, the pilot wants to lower their aircraft, what do you think that they should do with their lift? Should they increase their lift or should they decrease their lift? Exactly. They decrease their lift so that way gravity becomes stronger and pulls it down. And now if you want to go up, what would you do to the lift? Increase. Exactly. Good, everybody. So you want to increase lift to fight gravity so that way your airplane can start going higher in altitude. Now let's talk about now an airplane doesn't just float in the air, right? Like a kite. It actually goes forward. It has to move forward. Otherwise, it's not like a helicopter. It can't hover. So what force would you call this forward moving force? What do you think you would call it? Forward moving force. It's a tough word. It starts with a T. If you want to hop into Google real quick and do a quick Google search, I'm not going to stop you. Trajectory. Okay. Trajectory it is a very important factor when it comes to, flying an airplane, because you have to think about where you're going to take off and where you're going to come back down, right? So this is the ground here. This is the start point here. This is our trajectory, right? The arc that it makes. Thrust. Good job, Jennifer. So yes, this force is called thrust. And that is our forward moving force. So I want to bring it up a little bit. I know my lighting isn't the best, but this if I'm pulling on this airplane with my fingers using this arrow as an imaginary string, it's going to be called thrust. And the same way that gravity fights lift, there's a force that fights thrust. So as the faster you go, more of this increases. So it's always fighting thrust. What do you think that force is called? Now here's a hint. Yes, Jennifer, good job. Drag. Wow, you took my class before, huh? No, I'm just kidding. Yeah, my marker's dying. I'm sorry. So yes, this is called drag. So now, if I want to go at a constant speed, right? That means that I'm not going faster. I'm not going slower. I'm just flying at one consistent speed. What has to be true about my thrust and my drag? In relation to each other. Yes, exactly. It has to be equal or balanced, just like lift and gravity. Good job. Good job. Good job. I'm glad you're understanding this. So if I'm going at the same speed, my thrust and my drag equal each other. Now, what if I want to speed up? What should I increase or should I decrease my thrust? Increase. Good job. And again, if I want to, I want drag to win so it could start slowing me down, then I want to decrease thrust, right? So today we're going to do a project that doesn't focus on thrust and drag, but it focuses on lift and gravity. All right. So we're going to get started with this project, and we're going to basically build a DIY helicopter. All right. So the materials we'll need for a DIY helicopter are pretty simple. Just need a index card, or you could use cardboard, maybe like cereal box kind of cardboard, not like the super thick kind of cardboard. Or you could even use some construction paper. It's not as rigid as index cards are, but whatever material you have should work. If you have a paper that you don't feel is strong enough, why don't you try and just kind of like folding it over? And you just want to have one about the size of this. If it's a bigger piece of paper, you want to just cut it down to this size or fold it into this size to make it more rigid. And I'm using a binder clip, but you can just use a paper clip, whatever works for you. All right. So I'm going to give everybody about about a minute or two. I'm going to give everybody about a minute or two to collect the materials and just type in the chat window, hey, I'm ready.
Naved, would something like construction paper work well for this?
Construction paper would work well. I personally wouldn't use it, but if I am using construction paper, I would probably double it up.
Okay.
All right, what do we need? We need paper and a paper clip. I'm using a binder clip, but you can use a paper clip. That's just fine. And you'll need scissors. And you possibly might need a marker or a pencil or something like that to make the markings, in case you kind of need help figuring out where you want your lines to be. All right, and I'm going to be using a marker so you know exactly what to do, where to do it. All right, as soon as anybody is ready, just start typing it into the chat window. Hey, I'm ready. Uncle Jamel, you still here? All right, awesome. I got about 2 people ready so far. All right, Violet, thank you. All right, Melinda, thank you. All right, awesome. All right, I'm waiting for you, Violet. Anybody else that I should wait for, just let me know in the text window. Just say, hey, please wait. That's all. Or just wait. Okay, awesome, Amy. All right, Violet. All right, so what I'm going to do is I'm going to draw out a template so that I know where to cut and where to fold, because that's very important. We don't want to cut where we need to fold, and we don't want to fold where we need to cut. All right, so the first thing I want to do is I'm going to take a straight edge, like a ruler, or you could use the edge of a book or something like that, or you can even use another piece of paper as the edge. And what I'm going to do is is a paper clip or a binder clip better? Any of them will work. Binder clip will just add a little bit more weight. So a binder clip might cause your plane to fall down quicker than you want it to, right? Because remember, lift is fighting gravity, and gravity is directly related to weight, right? The more you weigh, the more an object weighs, the more gravity it's feeling. Another fun fact about gravity is that the gravity that you feel on Earth is obviously not the same in other planets that you might feel, right? Or even out in space. So gravity is a funny thing. It's a very funny thing. And scientists are still They're still discovering new theories about it. You know, recently we had a discovery about gravitational waves, and that just like boggled the minds of scientists everywhere. All right, so what we want to do is when we get our first piece of paper is we want to find the center of that piece of paper. And what I want to do is I just want to draw a line. I want to draw a line down to about halfway. Not all the way down, just about halfway there, to the halfway mark. So this is what that line will look like. All right, I'll give everybody a second or two to catch up with me. All right, now the next thing I'm going to do is I'm going to take about half an inch away from the bottom of this line. And what I'm going to do is I'm going to draw a horizontal line, but I'm going to give a little space between the horizontal line and this vertical line. So it's going to look something like this. All right, just like that. All right, if I'm going too fast, please just in the chat window, just write in, hey, please slow down, give me a second, or whatever you need, all right? And again, I just want to thank everybody for being patient. And all right, awesome, cool. Thank you. All right, so now what I'm going to do is I'm going to take this line right here and I'm going to divide it evenly into 3. So I'm going to draw 2 lines, and those 2 lines are going to split it into 3 sections. So I'm going to show you what that looks like. All right, and it should look something like this. All right. I'm going to give everybody a quick second. I know this part might be a little tricky. You might be trying to get it exactly right. Don't worry if it's not perfect. They don't have to be perfectly equal, but you just want to visualize and kind of just estimate and make sure it's, you know, at least a close approximation to equal. Okay, no problem, Violet. All right. Okay, so now the next thing I want to do is I want to make 3 cuts on this, 3. All right. So the first cut I'm going to make is going to be on just this portion of the line. The second cut I'm going to make is this portion of the line. And the last cut I'm going to make is this line right here, this entire vertical line, but only up to this point. And again, for these, I just want to cut this line. I don't want to cut this line. I don't want to cut this line. I don't want to cut this line. I just want to cut this line, this portion of the line, and this vertical line. All right. I seem to have misplaced my scissors somehow. So I'm just going to use my hand to cut through it. And if you're good with being careful about cutting through, then you should be able to still get a pretty clean cut. All right, and I want to do the same thing on this side as well. All right, and now you should see it's kind of like a little, like 2 little flaps. What I want to do is I want to take one of these flaps, fold it over in the front like this, and I want to take the second flap and fold it over that one, just like this. So now it kind of becomes like a little mini poster, right? Little protest sign. Tree, yeah. All right, so I'm going to wait. And then after that, you want to cut down the long way. I'm going to wait a little bit for everyone to catch up before I cut it down the long way. All right, so now what I want to do is I want to cut it down. Definitely, Leslie. All right, so I want to cut it down just until the end of this line. So I don't want to go past that line. Again, I'm sorry I don't have my scissors. I really don't know where it went. It'll probably pop up as soon as I'm done with this. All right, so now it's going to look like these two little flaps, just like this. And what I want to do is I want to fold this flap down. You know what? I'm going to give everybody a second to catch up. All right. So yeah. So if you know you don't know how to use scissors, that's okay. You know, paper is really easy to rip through, and straight lines aren't super necessary for this project. The next version of this project that you do, because we like to do something that's called iteration, and when we do iteration, you have your first design, then you improve on that, then you go into your second design, you improve on that, your third design, etc. Wow, that is a super powerful post, David. Really appreciate it, and thank you for your input. It's really really amazing what students I think are doing in this time. And if you have students on this call as well, just super proud of you handling this and taking this into your hands and really making like you in history. People will know that you went through this phase, and you will get to share the stories of what you did in this phase. And it's going to be very powerful. All right. So now next thing I want to do is I want to take these flaps and I want to just fold them down, but I want to fold them in opposite directions. So they're going to fold like this. All right. I don't want to fold them in the same direction. So they're both like this or they're both like that. I want to fold them in opposite directions. All right. So the first one I'm going to fold down like this. And when I fold it down, I want to make sure that I'm folding along kind of like here. Let me draw this out so you can see it visually a little bit better. So if you notice, I drew a horizontal line there, and I want to fold it along that horizontal line. So I don't want to fold it like this. I don't want to fold it like this, right? I want to fold it straight down this horizontal line. I want to do the same thing with this flap. But again, if I'm folding it this way on this side, if I'm folding this side, sorry, I'm getting that angle. If I'm folding it down this way, I want to fold this side down the opposite way. So now it should look like this. There is no specific reason for the increments of thirds. I just do it to give this bottom edge a little bit of rigidity. And yeah, you could do it into fourths or whatever it is that you'd like to do it. But I tend to see that doing it in thirds works really great. Okay, awesome. So now once you're done with this part, what you want to do is you want to take your paper clip, or in my case, a binder clip, and you just want to put it and hook it to the bottom like this. And what that does, it gives it a nice little weight, so that way gravity can pull it down. Now, I don't have a lot of screen real estate in front of me. I only have about 7 inches that you can see. So you might not see this twirling as well in front of you because it's It's just falling a very short distance. But, you know, if you throw it up into the air, you might notice that as it comes down. So what this paperclip also does, it brings the center of gravity lower on this object. So when you bring the center of gravity lower on this object, when it comes down, it doesn't come down like this, or it doesn't come down like this. The center of gravity forces this object to always be this edge to be at the bottom. Okay, so now once you have this done, you can give it a little toss in the air and see what it does. It should, like I said, I don't have a lot of or you can just throw it into the air and then see as it comes down, it will twirl. So let me try to do this. It's twirling. I apologize. You can't see it. But as it's coming down, you'll see it twirl. And there's different things you can do. Yes, it's twirling. Good. Awesome. I'm glad it's working for everybody. Awesome. So the cool thing about this is that you can do different things to this, right? Different iterations, different versions of this. Try to bend the wings a little bit. Try to cut the wings into a specific design, right? Because when we look at airplane wings or helicopter wings, they don't look like this, right? As simple as two squares, right? So think about what else you can do. Think about what else you can create using these blades, right? Yeah, so right now what we're seeing is when we throw it in the air, right? Because it's experiencing lift, that's what causes it to twirl. Because what happens is as it's coming down, the air is pushing against these wings. And because it's pushing against both of these wings simultaneously, it creates a turn. Okay, Violet, does yours look like mine? What's it doing? If somebody wants to share their screen, Latanya, I don't know if any of us have that ability on our end to approve someone to share. It might be a moderator who has to handle that. Oh, thank you, Latanya. Awesome. Good job, Cynthia. So Violet, if yours isn't working, try something different. Maybe the paper that you're using is too light, or maybe it's not rigid enough. You know, what do we talk about when we mean something that's rigid? Is that, you know, it's not like, you know, if I had an ordinary piece of paper like this, you know, it kind of like, it just kind of bends any which way I ask it to. But with this, no matter which way I bend it, kind of bounces back to its original position. And yeah, so like as it's falling, right, gravity is pulling it down, is generating some sort of lift. It's not generating a lot of lift, because if it was generating a lot of lift, what would this do? So right now we're seeing that it's generating lift, but it's falling. So that means gravity is winning, right? So I'm going to bring back my little whiteboard, and we see that gravity is pulling it down, right? And lift is pulling it up. But what does it mean about when this is just falling straight down? If the lift was greater than gravity, what would this helicopter do? It would ascend. Yes, good job, Aubrey. Thank you. Yeah, so I have one last quick little science, a little origami lesson with everyone to do. And so for this lesson, you want to grab a piece of paper. It doesn't have to be an index card, but something this size would be really helpful. We made a different one now and it works. All right, great. Good job. Now, does anybody, before I move on to this next one, I know we have about 12 minutes left. Does anybody have any questions about what you saw today so far with Hanna's experiments before me, or with my experiment that we just did right now. Any questions at all? If anyone wants to share their screen, show us their helicopter flying. Awesome, David. I'm glad that you're going to be using our experiments, and you know, we try to create more and more at-home experiments. You know, especially now during these virtual times, getting materials to our students' homes is a little difficult. So we're just trying to work in projects that are trying to, you know, be able to utilize the things laying around our house. I know there is a way to connect on here on Hopin. There's just so many different features on Hopin that some of them gets a little lost on my radar. But Latanya, if you can just remind everyone how we can connect with each other and we can exchange information. That way, if we have, you know, if you would like to, you know, talk shop or something like that, you know, we can do that. Or you could even find Stephen Gilman as well. All right, so what we're going to do now is we're just going to quickly do one last little origami session. All right, so what I want to do is I want to take this piece of origami, this piece of index card, and what I want to do first is I want to kind of fold it down about what I want to do first. I want to take this tip and I want to fold it along this edge. So now this top edge becomes in line with the side edge. So it's going to look something like this afterwards. All right. And then I'm going to open this up and I'm going to take this corner and I'm going to go towards this edge. And now when I open this up, now what you notice here is there's like a little X. All right, now what you want to do is you want to fold this down, but you want to fold it down so that way the fold goes right through that middle of the X. So just like this. All right. And now you'll have a little line that's going right through the middle of your X. So now what I want to do is I kind of want to push these edges out and keep my back pulled in so it kind of looks like this. And I just want to let it naturally fold into place. So it's going to look like this. It's going to look like this once I'm done folding it. All right, now that I had that, I'm going to take this tip. I'm going to fold it upwards towards the nose. I'm gonna do the same thing with the other side. I know that I might be going a little fast. I don't have a lot of time left. And I know this is being recorded. So, okay. So I know this is it's a little bit of a tough little origami session. So which part are you stuck on, Violet? Are you stuck on this part? So you kind of want to push it in. So it kind of looks like this, right? So you want to push those two edges in so it folds into each other like that. And then we want to just pull up. I want to take the corner of this triangle and I want to pull it up like this. Take the corner of this triangle and pull it up like that. All right. And now what I want to do is I want to take this edge. I'm going to fold it in so it kind of just tucks into that little space right there. Just like that. I want to do the same thing with the other side. And this is very difficult to do when you don't have like webcam turned on because I can't see what step you're stuck on. All right, I'm going to do this again really quickly after I'm done with this first one. So now that I'm done with this side, I'm going to take this edge, I'm going to fold it up just so I see a little bit of my nose still poking out. And then I want to take the same edge I folded up and fold it back down like this. And now after I do that, what I have here is a little frog. Hip, hip, pop. And you could even pull it down and it jumps. Okay, now I'm going to do this again. So I'm going to take my little piece of paper. It doesn't have to be the index card, but you just want to make sure that it's relatively this shape. Yeah, awesome. Good job. That's riveting. Awesome. All right, so I'm going to take this top right corner, and I'm just going to fold it down, and I'm just going to fold that just like that. And I'm going to open it back up. I'm going to take the opposite corner. I'm going to fold it out the same way to the opposite edge. Just like that. All right, now I see a little imaginary X. Now what I want to do is I want to take my paper and I want to fold it so that my fold goes through the middle of that X. So now it's going to look kind of like this. Let me get some good lighting so you can see that middle fold. All right, so now that I have that middle fold, what I'm going to do is I'm kind of just going to like push out. So if the fold is the other way, I'm going to push out. I'm going to push the other side out as well. Awesome, Violet. Good job. So now that I'm pushing both of these edges out, whoops, and I'm just going to fold it down. And now when I do that, you'll notice that it's kind of making this little unique shape. I call it a unique shape because I don't really know what the name of the shape is. All right. So now that I have it folded here like this, and I have the flaps on this side, I'm going to take one flap. I'm going to fold it up towards the nose. Take the other flap, fold it up towards that nose. All right, now that I'm at this step, I'm going to take the side wing, fold it in, tuck it right into that space. So you see there's a little triangle, and this triangle can tuck right in to this space right here. I'm doing the same thing with the other side. Just like this. And then what I want to do is I want to just take the bottom. You see how my frog folds out? So the direction it folds out is a direction I want to fold up. I just want to fold up just so that a little bit of a nose is peeking out. And then I want to fold this back down, but halfway. Just so that the bottom edge touches the top edge touches the bottom edge like that. And then now you have your little frog. You can do a little hop. Awesome. Good job, Antoine. All right. So everyone, please, I just want to thank everybody for joining us today. Again, we are MakerState, and we're here in New York City, and we are doing a lot of fun virtual things. So if you want to connect with us, Stephen already posted his email. I'll be posting my email as well. So in case you have any emails, you want to bring some of it. We have, a bunch of curriculum that, if you need help kind of morphing this online learning, STEM learning into your classrooms with your students, or you just want to have some more projects in hand. Thank you. I'm going to pass the mic back to Josiah.
All right. Thank you so much, Naved, Stephen, Stephen, and Hanna. Thank you so much, MakerState.